Hello. Today, with so many people concerned about global warming, it's not surprising that archaeologists have also turned to that topic. In fact, it has a longer history in archaeology than you might imagine. And in today's video, I'd like to review some of that history, as well as look at more contemporary archaeological studies that make linkages between rapid climate change events in the past and changes in human society and culture. Towards the end of the video, I'd also like to look at the question of how we can tell whether or not the apparent linkages are simply coincidental or actually causal relationships.
One of the earliest modern proponents of the idea that climate change was ultimately responsible for a lot of cultural changes was Raphael Pumpelly, an American geologist. In 1903, he mounted an archaeological expedition to the site of Ano in Turkmenistan, Central Asia. The ebb and flow of this site's fortunes, and especially its eventual abandonment, led Pumpelly to think that climate change was responsible. Specifically, he said, evidence has been traced of a progressive desiccation throughout long climatic cycles, in whose favorable extremes civilizations flourished, which disappeared in the arid extremes, and that the climatic conditions under which these civilizations vanished gave rise to very early migrations and to a constructive reaction upon the outside world, which seemed to follow from the early appearance, in Babylonia and Egypt, and in the late Stone Age in Europe, of wheat and barley and breeds of domestic animals. With these words, Pumpelly foreshadowed the so-called Oasis Theory of the Australian archaeologist V. Gordon Childe. Childe thought that the conditions of the Pleistocene Ice Age were not conducive to the origins of agriculture, but that towards the end of the Ice Age, rain-bearing winds would have passed over what is now the Sahara Desert. He thought that this would have caused what is now the Sahara Desert to be savanna and grassland, attractive to livestock. He thought that abundant North African rock art that depicts people hunting cattle and other ungulates supports this view, but that a northward shift in the rain-bearing winds during the first few millennia of the Holocene caused the Sahara to become the desert that we know today. Such conditions were less and less hospitable to those livestock and the people who hunted them. According to Childe, this would have caused both people and animals to congregate near oases, which would eventually become the only source of fresh water and vegetation. Childe thought that this enforced proximity would have caused people to become more familiar with the habits of those animals. According to him, enforced concentration in oases or by the banks of ever more precarious springs and streams would require an intensified search for means of nourishment. Animals and men would be herded together around pools and wadis that were growing increasingly isolated by desert tracts, and such enforced juxtaposition might promote that sort of symbiosis between man and beast that is expressed in the word domestication. Although some aspects of Childe's theory seem plausible, there were also some problems with it. For one thing, the beginning of the Holocene would not have been the first time that human beings had experienced climate change, and this begged the question of why domestication of plants and animals had not occurred earlier. And it implied the assumption that prehistoric hunter-gatherers were ignorant of the habits of the animals they hunted. This is a highly implausible assumption. Finally, Robert and Linda Braidwood, archaeologists from the Oriental Institute at University of Chicago, decided to try and test Childe's hypothesis. From 1948 to 1955, they mounted an expedition to Iraqi Kurdistan, with excavations focused mainly on the site of Jarmo. The Braidwoods had a multidisciplinary team, including geologist Herbert Wright and paleobotanist Hans Halbeck. Together, they documented some of the early evidence for the domestication of plants and animals, and also came to the conclusion that Childe's Oasis theory was incorrect, because, at least in this region, domestication was able to occur without post-Pleistocene desiccation. In the 1960s, an increased interest in the environment and environmental activism corresponded with an increase among archaeologists in environmental archaeology, including climate change. One archaeologist, very closely associated with the beginnings of the so-called New Archaeology, was Louis Benford. Benford tried to get around the flaws in Childe's Oasis theory while still focusing on some of the environmental implications of the end of the Ice Age. Binford noted that the late Pleistocene and early Holocene were associated with major changes in world sea level, and that the sea level rises would have had particular impact on coastal populations. Binford thought that coastal areas in places like the eastern Mediterranean would have been extremely attractive for settlement during the late Pleistocene. The availability of fish and waterfowl would have led to higher degrees of sedentism and higher population densities, as evidenced by Natufian sites in the southern Levant. Binford saw both these coastal populations and ones farther inland as living at or below the carrying capacity of their territories. The inland carrying capacity was lower than that along the coast, but in both areas populations grew until they reached equilibrium with their environment. Or perhaps their populations oscillated a bit before settling down to a steady state just below the carrying capacity. If inland populations were far enough below their carrying capacity, communities in the coastal region could deal with their own population increases, in part by having some members of their group migrate inland to maintain their population below their own carrying capacity. However, the loss of massive areas of coastal plain to sea level rise in the late Pleistocene and early Holocene would have forced these coastal communities to increase their rate of migration, and one of the more obvious alternatives was to migrate inland, where the migrants impinged on the territories of indigenous people whose populations were just below the carrying capacity of those territories. As Binford puts it, the intrusion of immigrant groups would disturb the existing density equilibrium system and might raise the population density to the level at which we would expect diminishing food resources. This would have put stress on local resources, and Binford argued that that accounts for people's investment in domesticating plants and animals. While Binford's theory doesn't really hold up to current evidence about the origins of plant and animal domestication in Southwest Asia, it does nonetheless illustrate the kind of climate-related hypothesis that became popular for a while in the 1970s and has had a resurgence in the last 20 years or so. Today, it's hard to deny that the massive increase in archaeological hypotheses that view climate change as some kind of trigger is related to modern concerns about global climate change. As we search for ways to adapt to global warming that nowadays seems to be pretty much unstoppable, some research have turned to archaeological evidence associated with past rapid climate change events to see how those events may have impacted human cultures. Before we move on to look at recent theories that connect past climate change events with changes in human culture, let's look at some of the methods that are used to detect those climate change events in the first place. Among the premier sources of evidence for ancient climate change are cores drilled through the ice in various glaciers in Greenland. These ice cores provide very precise records of fluctuations in the ratio of oxygen 18 to oxygen 16, described with the shorthand delta oxygen 18. Because these two isotopes of oxygen have different evaporation rates, and because the heavier oxygen 18 precipitates before oxygen 16, high values of delta oxygen 18 are correlated with cold temperatures, while low values indicate warmer temperatures. We can also date the fluctuations in the sequence by carbon dating carbon dioxide that's trapped in the ice. What you see here are BP dates in thousands of years before 1950. The graph not only shows the cold period of the last glacial maximum and the Pleistocene, but the rapid warming event at the beginning of the Bowling-Allerode period, the Younger Dryas cold episode that followed that, and then another warming episode at the beginning of the Holocene. Throughout the Holocene, there are much smaller fluctuations in temperature. While we might reasonably expect temperatures in Greenland to have some relationship to global climate changes, it's also reasonable to expect local conditions to vary across the planet. Consequently, archaeologists and paleoclimatologists also rely on other sources of evidence, some of which are more reflective of local conditions, such as pollen sequences from cores taken in lakes and bogs. Variation in the relative abundances of pollen from different kinds of plants can indicate such things as changes in the extent of forest cover, which can be due, at least in part, to changes in climate, although human impacts can also be very important. And we also have to be mindful that some kinds of pollen can be carried very long distances by wind. Consequently, One of the best sources for very local climatic impacts comes from geomorphological analysis of sediments in stream banks. The sequences of colluvial and alluvial deposits in these stream banks can reveal changes in the volume and intensity of precipitation, or reveal erosional events associated with widespread deforestation. A very useful source of evidence for local climate histories in limestone regions comes from karstic caves. In these caves, we often find speleothems. These are the stalactites, stalagmites, and other kinds of flowstone that occur from the deposition of calcium carbonate. When rain falls on the surface above the cave, water percolates down through the soil and rock, picking up calcium carbonate and other minerals on the way. When that percolating rainwater reaches the walls and ceilings of the cave, some of those minerals precipitate out. And the deposited minerals forms rings in the stalactites, stalagmites, and other speleothem formations. Generally speaking, the more rainfall there is, the thicker these rings will be. And consequently, the ring thickness varies over time. And we can also date the rings by using uranium-thorium dating. In addition, we don't have to rely on ring thickness alone. As with the ice cores, we can also look at oxygen isotope ratios. During very heavy rainfalls, there tends to be a higher proportion of the lighter isotope of oxygen, and to some extent, the oxygen in the carbonate that makes up the speleothems tends to reflect that. Some ancient climate events have drawn particularly strong interest from archaeologists, among them the Younger Dryas period. The Younger Dryas was a relatively cold and in some places dry millennium that began around 13,000 years ago. Although scholars disagree on what caused the Younger Dryas event, some of them attribute it to the impact or perhaps the airburst of a comet that had allegedly entered our atmosphere around that time. In fact, Andrew Moore, a professor at Rochester Institute of Technology, and his colleagues have argued that the epipaleolithic site of Abu Huraira in central Syria was probably destroyed by this cometary burst. While other archaeologists have implicated the Younger Dryas period either to changes in epipaleolithic hunting technologies or in the origins of agriculture, while some others have implicated the Younger Dryas in the extinction of the Pleistocene megafauna in the Americas. Whatever the cultural impacts of the Younger Dryas may have been, some renowned scientists have vehemently refuted the hypothesis that the Younger Dryas was caused by a cometary impact or airburst. Presumably, this research will not be popular among those who want to make the unsubstantiated claim that there was a highly complex Pleistocene civilization that this comet allegedly wiped out. I'll save this controversy for another video, but meanwhile, let's return to the climate events that archaeologists have tended to focus on. One of the most significant impacts of the rapid melting of glaciers during the temperature rise of the early Holocene was a major rise in global sea levels. From the end of the Younger Dryas until about 5,000 years ago, global sea levels rose by more than 60 meters. In previously glaciated areas, isostatic rebound sometimes lessened or even reversed this trend. But in regions that had never seen glaciation, the impact on low-lying coastal areas was dramatic. For example, along Israel's Mediterranean coast, the rising waters swallowed up Neolithic villages, and archaeologists have discovered and explored several of these, which show evidence for wells, houses, storage facilities, cemeteries, and even possible ritual structures. Rising waters of the North Atlantic and North Sea also flooded the land bridge that once joined England to the European continent. This archaeologically rich submerged landscape is known as Doggerland, and probably contains the remnants of a great many undiscovered Mesolithic settlements. Some archaeologists have also tried to associate a relatively brief cold snap, known as the 8.2 kiloyear event, with the demise of the pre-pottery Neolithic B period in the Levant. However, this inference appears to be due to confusion over the dating of the end of the PPNB, and on current evidence, most village abandonments of the pre-pottery Neolithic appear to have occurred many centuries before the 8.2 kiloyear event. while some Neolithic villages, including Ain Ghazal in Jordan, appear to have thrived during this period, continuing well into the Pottery Neolithic. As long ago as the early 1990s, some archaeologists and climatologists argued that an aridification episode around 2200 BC caused the abandonment of many Mesopotamian cities and the collapse of the Akkadian Empire. It might seem to make sense that increases in the severity or frequency of droughts would undermine the agricultural basis for these cities. But we also have to keep in mind that most Mesopotamian cities were already well below the 200 millimeter isohyet that's usually considered the minimum that's necessary for dry farming, and that their agriculture actually depended on irrigation. Although it's conceivable that reduced precipitation in the mountains north of Mesopotamia could have resulted in lower water levels in the Euphrates and Tigris rivers, it's less certain that any such reductions would have been severe enough to result in a complete societal collapse. Today we tend to be worried about the negative implications of global warming, but interestingly, most of the archaeological studies of ancient climate change are more concerned with negative impacts of cold climate. That's because, in some parts of the world at least, cooler climates are also associated with drier conditions. However, if we really want to understand the impacts of climate change on human cultures, such warm, cold, good, bad distinctions are really too simplistic. We need to think instead about the specific implications of specific climate changes in particular regions and under particular economic circumstances. Intuitively, it makes sense that some kinds of climate change, at least in some regions, should have had impacts on cultures and economies. For hunter-gatherers, some kinds of climate change could lead to changes in the frequency, distribution, or migratory patterns of the animals they hunted. And for farmers, increases in the severity or frequency of droughts could have disastrous impacts for agricultural productivity. And in some cases, desertification could have immediate impacts even on the viability of settlement. But the impacts of global climate changes are not evenly distributed. If we want to argue that aridification caused site abandonments, for example, we should be able to demonstrate that the earliest abandonments occurred in the regions that were most likely to be impacted by climate change, while abandonments occurred later or not at all in areas that were better protected or had alternative water sources. We should also be mindful that the impacts of these cooling episodes are not uniformly negative. So even where they're associated with lower rainfall, they're also associated with lower evaporation rates. So the overall impact on available moisture might be less than you'd expect. As just noted, it's been common in the last decade or so for archaeologists to note that some of these climate changes seem to be associated with important cultural events. However, we should be cautious of these associations. Not only should we be mindful of the old maxim that correlation does not necessarily indicate causation, we also need to remember that there is no time in this entire sequence when there was nothing happening at all. In other words, we can take any wiggle in a graph like this, and if we look hard enough, we can always find some kind of cultural or economic thing that was happening that could have been caused by some climate change, or could have had nothing at all to do with climate. For example, there's a small but sudden drop in temperature around 2900 BC. This corresponds, more or less, with the early urbanism of the early dynastic I period in southern Mesopotamia, and with the Dawenku culture in China, and possibly the beginning of the Corral culture in Mesoamerica. But there's no reason to expect that climate change should have anything to do with any of these cultural changes. There's also a rapid rise, then fall in temperature around 1250 BC, and one might be tempted to associate that with the migrations and attacks by sea peoples in the eastern Mediterranean. But there's no clear indication that these movements had anything to do with climate change. And they happened at a time when some other civilizations, such as the Olmecs, were having a period of stability. And the Olmecs' major city, San Lorenzo, was abandoned not in 1250, but around 900, when there was no significant climate change, according to the ice records. Similarly, there's a steep downturn around 30 BC, but it would be pretty simplistic to blame that for the rise of Octavian as Emperor Augustus and the beginning of the Roman Empire. There's also a small downturn about 1,000 years ago. Yet this didn't prevent the establishment of Scandinavian settlements in Greenland or the construction of large mounds and other public architecture at Cahokia. In case you're wondering why you don't see a large upturn due to recent global warming, the 0 point on this graph is 1950, almost 75 years ago. The more general point is, of the thousands of events that occurred over the course of these periods, how many of them can plausibly be attributed to the climate events associated with those wiggles in the graph, and how many of those associations are just by chance? To make that distinction, it's incumbent upon us to find the causal chain that links the climate change to the cultural changes. For example, is there evidence that the agricultural systems were particularly susceptible to drought? Is there evidence for shifts to more drought-tolerant kinds of crops? Were there new attempts to dig canals for irrigation? And were the first site abandonments in the regions most susceptible to crop failure? Only by specifying a chain of causation and identifying evidence for the links in that chain can we be confident of the association between cultural changes and climate change.
As I hope I've shown you today, it would be surprising indeed if ancient people did not respond to major climate events, whether by making changes to their economy or perhaps migrating to another region where the circumstances were better. On the other hand, some of these theories go as far as saying that there was complete societal collapse, which may have occurred in some cases. However, in order to make strong conclusions in that regard, it's necessary to be able to demonstrate that the linkages between climate and the societal changes were actually causal ones and not just coincidences.